Hey there, folks. In this video, we are going to be discussing graphing exponential functions. Now, just as a quick little reminder, exponential functions are written in the form of a times b to the x power. So a is going to be our y-intercept, and then b to the x power. This b is the base of the exponent, and that determines whether our graph is a growth or a decay. Now, just as a heads up, in this unit, our a value is either going to be 1 or -1 every time. That means your y-intercept in this unit will either be 1 or -1 every single time. Obviously, there are graphs out there that do not have those those y-intercepts, but just for simplicity's sake, in this unit, when you guys are getting used to how these things behave, that's what we're going to use. Now, you will see different values for b. Now, the b value is going to determine basically how sharp of a curve or how drastic of a curve your exponential function has. So, for instance, a 2 to the x graph might look something like that, whereas a 5 to the x graph might look something like, that's not a good example, might look something a little bit sharper of a curve. Okay, so the bigger the base, kind of the sharper that curve upward is going to be. So that's the general gist. Now, let's get into how we could transform these. And you're going to see a lot of similarities to our previous function units and function discussions on transformations. If we add a number or subtract a number outside after the function, that's going to move things up or down. Now, keep in mind, these functions also have an asymptote. And the asymptote is typically it's on the x-axis. However, if I move my function up or down, the asymptote is going to kind of move along with it. So the vertical shift is also going to be the y equals asymptote value. The horizontal shifts are going to take place inside the exponent where the variable is. Just like before, a minus sends it to the right, a plus sends it to the left. And with reflections, if you have a reflection in front of the entire function, then it would reflect over the x-axis, so it gets flipped upside down. And if you have a negative inside the exponent, that reflects about the y-axis. And the reason why that works is, I'm just going to make up an example. If I had 2 to the negative x power, that's technically the same thing as me saying 1/2 to the positive x power, right? And 2 to the x power graphically would be a growth function, whereas 1/2 to the x power would be a decay function. So essentially, these two graphs are just reflections of one another over the y-axis. Okay, so let's just get some practice identifying the transformations. We don't particularly care about the base number here. What we're looking for are numbers being added or subtracted up in the exponents, or maybe negatives. We're looking for numbers being added or subtracted after the function, because that'll shift up and down. Or maybe we're looking for negatives out front. Those are all going to transform my function in some way, shape, or form. So this first one, I'm seeing a +4 in the exponent with a +7 on the outside. Well, this plus on the outside goes up. Plus in the exponent is going to shoot it to the left. So we're going left 4, up 7. Here we've got a negative sign. Well, negatives tend to indicate reflections or flips. So I'm going to have a reflection, and then we go down 10. And that reflection is over the y-axis. And last and certainly not least, we have a negative out front, so it's going to flip upside down. We're going to go to the right 2, and we're going to go up 5. So just identifying transformations there. Well, now let's go ahead and let's try to graph one of these beasts. Now, what I'm going to do is I'm going to show you what an original graph would look like, and then we're going to transform it, okay? So normally, a plain old y equals 2 to the x power. I've got my asymptote there with my y-intercept at 1, okay? There's technically a little 1 chilling out front there if I wanted to think of that as a times b to the x. Now, if I move my asymptote up or down, that y-intercept also moves up or down. If I move the asymptote left or right, the y-intercept also moves left or right. However, when I move the asymptote left or right, it doesn't really change the value of where it's at, right? Because right now, if I'm on the x-axis and I move left and right across the x-axis, it doesn't really change the asymptote value. So up and down movements are the only things that'll change the asymptote. All right, so let's see what we have here. I'm seeing this plus 3, so I'm going to the left 3 units. So I'm going to take this graph and go, hey, no. And I'm going to go left 3. So 1, 2, 3. Now my asymptote is still going to be on the x-axis, right? I didn't shift it up or down at all, so it's still going to be y equals 0 on the x-axis. My domain, every single one of these, is always going to be negative to positive infinity, so that should be a gimme. And then my range is always going to tie in with my asymptote value. My range is going to go from 0, and it's going to go up forever. When I go to graph this, since it's a growth, it's going to be kind of this shape. I need to go through that point as best as I can, and then go upwards. Now, if we wanted the new y-intercept, and I'm not going to lie to you, I was very sloppy here, I could plug in 0 for x, right? So I'd get a y-intercept of 2 to the 0 plus 3, well, that's 2 to the third, that would be 8. So I could get an actual y-intercept of 0, 8 if I wanted some more exactitude to my graph. Let's take a look at another one. We have 1/3 to the power of x minus 2. So the fact that it's a 1/3, I know it's going to be decay, and I know it's going to go down 2. These graphs typically look like the following. We have our asymptote on the x-axis, and the y-intercept is at 1. Now, according to our transformations here, I need to shift that down 2 units. So 1, 2. I haven't shifted it left or right at all. My new asymptote is going to be negative 2. So y equals negative 2. My domain, that should be easy. Always negative, positive, infinity. And if I graph this general shape to align with this setup, I'll get something that looks roughly like that. Try your best to go through that point. So my range now, again, if I go from the lowest point to the highest point, would be from negative 2 to positive infinity. And just as a reminder, the low point, or whatever value is by the asymptote, always has to have a parenthesis because we never actually reach that value of negative 2. All right, next one. We have negative 2 to the power of x minus 2. It might help some of you to think of this as negative 1 times 2 to the power of x minus 2. Now, normally this would be a growth function, so I'm going to sketch this out. Normally, my graph would look something like that. But it's been flipped over the x-axis. It's been flipped upside down, so now it's actually going to look something like that. And it also kind of makes sense because my y-intercept should be at negative 1 this time around. So I'm going to sketch out kind of what we've got. I'm going to sketch out my asymptote, and again, this might move around, that's okay. And then the y-intercept now is going to be underneath because we got flipped. So let's go through what we have. This thing gets flipped, so there's been a reflection. And it's going to go to the right 2 units because of this minus 2 up there. So let's take this asymptote in this setup, and we're going to go to the right 2 units. So there's my new setup. It didn't shift up or down at all. So the actual asymptote value, the height or depth of the asymptote doesn't change. So my asymptote is still at y equals 0. Domain, again, should be easy. It's the same thing every time. All real numbers, negative to positive infinity. And now my range is going to be slightly different. Since I've been flipped upside down, instead of going from the asymptote value up to infinity, that's no longer going to be valid. Because my graph goes down forever. So it's actually going to be negative infinity all the way up to 0. Also, as a reminder, if you ever have a negative infinity as part of your domain or range interval, it always has to be on the left side. Positive infinity always has to be on the right side, regardless of what your other value is. All right. So now just a few examples for you. If we have 1/2, that would be a decay function. It got moved left 4, down 3. So it normally started off as a y-intercept of 1, but it goes left 4, down 3. In moving down, the asymptote, which was normally on the axis, comes along with it. So the asymptote goes left 4, down 3 as well. Another example for you guys, already worked out. We have 3 to the power of negative x. So yes, it should be a growth, but it got reflected. So it's going to look as if it were a decay. And we go up 5 units. So this graph, which would normally start off with the asymptote on the x-axis and a y-intercept right above it, has now been shifted up 5 units to that spot there. Again, your asymptote value should always match that vertical shift, just as a reminder there. All right, that is it. That is all. This will kind of make more sense with more practice, but you guys know the drill. If you have any questions, please let me know. And as always, folks, good luck, have fun, be safe, roll tide.